This video will take you through how your students are learning multiplication in 3rd and 4th grades. Notice the first 3 sections of this video are all about modeling. Modeling in multiplication is so important so that your student understands conceptually what multiplication is and what it looks like. In this video, you'll also see how the area model shows the relationship between multiplication and division. And lastly, you'll see how learning our fast facts really isn't that difficult, but is very important in our multiplication understanding.
This chart shows the progression our students go through as they learn multiplication from 3rd to 5th grade. The chart moves from left to right in difficulty. In the first 2 columns, the chart also moves from top to bottom in complexity. The last column, titled 5th grade, shows 3 different strategies that we would be okay with our students using as their primary strategy to solve multiplication problems at the end of 5th grade. These strategies are efficient and work for all numbers. In the upper left corner, titled 3rd grade, is the most basic form of multiplication that we see in 3rd grade students at the beginning of the year. As the year progresses, students show more complicated versions of multiplication. For the most part, we are going to focus on the early part of the progression and the area model.
This slide is meant to highlight some of the early strategies that your child may be using when they're learning multiplication. In this story problem, Rosa bought 6 bags of marbles. There are 8 marbles in each bag. We want to know how many marbles did she have altogether. Take just a minute to think about how your child might answer that question. One of the early strategies for solving this type of problem that you'll probably see in your child in 2nd and early 3rd grade is this equal groups model. In the equal groups model, your child could potentially draw 6 circles, which actually represents those 6 bags of marbles. They then place 8 marbles within each bag. Generally, students will just place tally marks or lines or circles, as you can see in this presentation, to represent each of those 8 marbles. The problem now becomes they have to add all of those marbles up. For this reason, the strategy of equal groups is quite limiting because adding by ones is time-consuming. Next, you'll find that kids will actually say, hey, this is like repeated addition, adding 8 6 times. They'll then see that 8 plus 8 equals 16, and another 8 plus 8 equals 16, and another. And then, building up, they'll know that 16 plus 16 equals 32, and then lastly, 32 plus 16 gets them that answer of 48. Another strategy is this idea of counting by 8s. One group of 8 is 8, 2 groups is 16, then 24, then 32, then 5 groups of 8 is 40, and lastly, once they've counted 6 groups of 8, they have 48. What we want to move your student to is this idea of the array. You'll see this array coming up. In this array, on the left, we see that there's 6 bags of marbles. Within each of those 6 bags of marbles, there's 8 marbles, just as the story problem tells us. We now can see that the area of that array is actually 48. This array opens up the possibilities for how your child can see multiplication and get answers for multiplication equations. You'll see more of this as the presentation continues.
The Bridges Math program used in 3rd grade uses a variety of games to get at critical concepts of multiplication. These cards come from a game called Count and Compare. The card on the left is the equal groups model, the most simplistic version for multiplication. The middle card is skip counting, and on the right is the area model. The grid used on the card on the right is a familiar grid for many 3rd graders. It has dark lines at the 50, and the 5 to make splitting up that array easy. A student who plays and gets this card might be able to break up that 3 times 7 into a 3 times 5 and a 2 times 3 to add it together to get that total area.
In this slide, we're going to show you how we move students from the equal groups model of multiplication to the very important array or area model. In this scenario, we're looking at there being 3 cars in a parking lot with 4 people in each car. We want to know how many people were in the parking lot altogether. In the equal groups model, if a student were to model this with tiles, they would actually show 3 groups of 4 tiles. Each group is representing a car, while each of those 4 tiles within a group is representing the 4 people. We can see in this model that a 3 times 4 equals 12. But when we think about doing multiplication with greater numbers in this model, it's quite limiting, and we'll show you some of those reasons. When we move to the area model, we then actually see that this dimension that you see on the left actually represents the 3 cars. And the dimension on the top actually shows that there's 4 people within each car. We can then move one of those equal groups into the array to show a car with 4 people, and yet another car, and yet another car. Looking at both of these models, you can see the 3 times 4 equals 12. But again, looking at that array, you can see it in the line across. That first car with 4 people, second car with 4 people, and lastly the third car with 4 people. One of the benefits to the array is the fact that we can switch this array, and we can actually be thinking about if the problem had changed. Now we have 4 cars in the parking lot and 3 people. Notice I've just changed those labels on the array. On the top you can see there's 4 cars, and on the side there's 3 people in each car. You can see by the purple there's 1 car with 3 people, a second car with 3 people, a third, and yet a fourth. There's a limitation on the equal groups model because you could see you'd actually need to rearrange that picture of 3 groups of 4 to have 4 groups of 3. At this point, you've seen a few slides that show the importance of the array. We'd now like to show you how we use this 100 grid to help students begin to break apart arrays. As you can see on this 100 grid, there are 100 squares. The 100 grid is divided at the 5s, both horizontally and vertically. This is so students can break apart those numbers using the 5s. In this slide, we're going to show you how a student might show a 3 times 6. Notice the dimensions on the bottom are 3, and it's 6 tall. Again, using that 5, we can see that there's the 5 mark that's underneath it. A student who's just learning multiplication may first see that there's a 3 times 5, which equals 15. That could be a fact that they already know. In using this 100 grid, they can then see that the 1 times 3 is still left over, and therefore there's an area of 18. If you add the 15, add 3. This array has helped us to see that 6 times 3 equals 18.
The purpose of this slide is to show you that the array model is better than other models of multiplication. We're going to use the problem about 9 vendors at the Barre Farmers Market. Each of the vendors has 13 products for sale. How many products were there in all? There's several models that we could use to solve this problem. The students will use to solve this problem. One model is to draw groups and put the 13 items in each group. At this point, the student's stuck without a clear strategy on how to make this problem easier to solve. Another strategy is to write 13 plus 13 plus 13, 9 13s. 9 groups of 13. Again, to break this up and to make it easier to solve, students will put 13s together, which will take quite a while. The array model is much better, and I want to show you many strategies that students will use in classrooms to solve this. One strategy is to do 9 times 10, which is easy to see in the array model. That's 90. Then you're left with 9 times 3, 27. You'll add those together for 117. Breaking it apart in this way was easy to see with the array model, but seeing that 90 from those stars or from those 13s takes a little bit more work. Another strategy a student could use using the area model is actually pretending that the array model was bigger. Instead of having 9 vendors, what if we pretended there were 10 vendors? Well, 10 times 13, that's an easy problem to solve, 130. To get to the original of 9 vendors, we're going to have to take away one group of 13. So 130 subtract 13 is 117. That is much easier to see with the area model. And yet, another strategy a student could use is to do 9 times 12, using a fact that he or she already knows, 108. And then that little edge right there, that's an extra group of 9 that you would need to add to 108. 108 plus 9 is again 117. There are many more strategies that you can use, many ways you can break apart that area model to make it easy to solve. Students are given that flexibility, whereas the equal groups model, they're really stuck with only a few handful of ways. Up to this point, we've tried to show you that the array is a superior model to the equal groups model for multiplication. It can help students figure out multiplication facts, and now I'm going to show you that it can help a child solve division. The same model to help solve division. Let's take 24 divided by 4. Division is talked about in all sorts of ways. It's talked about the fairest game in town. It's talked about sharing equally, splitting up, counting groups. Let me take a moment to explain this term, the fairest game in town. This term means that each group needs to have the same amount in it. That's why we get those remainders. I often talk to students when we're talking about division to think about that first number, the total number, as cookies. And we're going to talk about that to help us understand it here. 24 cookies shared equally among 4 friends. When we're using the array as our model, what we know is what's going to be inside the array. Those on the side are all of those cookies, 24 of them, ready to be put into our array. The other part that we know is that there are going to be 4 equal groups, 4 friends. Again, you've seen before that we use these linear pieces to show those 4 friends. And kids will put give one cookie to each friend, and then 2 cookies, 3, 4, and so on until all of the cookies have been put into the array. Again, we already knew what was going to be in the array, and we knew how many groups there were going to be, 4 friends. But what we didn't know was how many cookies each friend was going to get. And when we put it in the form of a rectangle, we can see that there are going to be 6 cookies for each friend. When we're using the array to solve multiplication, what we know are the 2 dimensions. We would know that there are 4 friends, and we would know that there were 6 cookies for each friend, but what we wouldn't know would be how many cookies that would be. For division, it's different.
This slide uses the area model to illustrate the relationship between multiplication and division. You can see that this area model is a 6 by 5. As soon as we see the dimensions are 6 times 5, we can see that 6 times 5 equals 30. We also can see the multiplication equation 5 times 6 equals 30. Now notice that the 5 has actually disappeared. This is actually now showing us the division problem 30 divided by 6. We know that that missing dimension is a 5, and therefore that division problem is 30 divided by 6 equals 5. Likewise, now you'll see the other dimension has disappeared. This now shows 30 divided by 5, which we know equals 6. In this way, we can see that this one picture of 5 times 6 equals 30 shows all 4 of those equations.
This is a good time to talk about multiplication facts. Any student that does not know all of the facts from 0 to 12 is at a disadvantage in math class. And any fifth grader that doesn't know all of the multiplication facts will struggle in 5th grade mathematics. This tool is the multiplication matrix, a tool that we use with students to show them that once we look at all of the facts that we have strategies for, there won't be a lot of hard ones left to learn. The way this tool works is if you look at the numbers in orange down the left and across the top, these are the two sets of numbers that we're going to be multiplying by. The smallest fact is 1 times 1. And if you draw your fingers over and across, you get to that first box in the upper left corner that is the answer to 1 times 1, or 1. The largest fact on here is 12 times 12. If you put your fingers on the two 12s and slide your fingers across the matrix and down the matrix, you will come together at the number 144 in the bottom right corner. That's the answer to 12 times 12. Any fact between 1 times 1 and 12 times 12 is on this matrix. Beginning in 3rd grade, we talk to students about the importance of learning the multiplication facts. We use this tool, the multiplication matrix, to help show them that there actually aren't a lot of facts they need to memorize. Students often know anything times 0, which is not on this chart, is 0. That's a quick one to learn. They also learn that anything times 1 is just the other number. Once they know times 1, they can talk about times 10, being that it is the other number moved over a place value. So instead of 3 times 1 is 3, 3 times 10 is 30. After talking about times 10, we talk about times 5. Times 5 is just half of times 10. When a student is presented with 8 times 5, we tell them to do 10 times 8, which is 80. And then cut that answer in half. Half of 80 is 40, which is the answer to 8 times 5. Next, we talk to students about times 2, which students will call doubling, because all you're doing is taking the other number and adding it twice. So 8 times 2 becomes 8 plus 8, or 8 doubled, which is 16. Students often talk about times 4 as double the double, which is if you had 9 times 4, you would do 9 plus 9, which is 18, and then add another group of 18. That's doubling and then doubling again, hence double the doubles. Finally, another easy fact family is times 11, because we know that 11 can be broken up into 10 and 1. So 8 times 11 is just 8 times 10 and 8 times 1, or 88, put together. Those facts are easy up until we get to 10 times 11. After that, those last couple, including 11 times 11 and 11 times 12, are harder for students to learn. This line, this black line cutting diagonal through the matrix, is here to show kids that The two sides are a mirror image. If you can find 4 times 8 on one side, you can also find 8 times 4 on the other side, which means you don't need to learn both of those facts as if they're separate. It means we only have half as many of the white facts, the facts that we haven't found a strategy for yet, to learn. In all honesty, we actually have strategies for all the rest of these facts, but we teach them individually as kids learn them.
It is important to help your child learn all of these math facts. Flashcards are a good tool. First, they're actually very inexpensive. You can find them at the dollar store or Walmart or Staples for usually under a few dollars. Flashcards are a great tool. You can use them and make piles so that you can then see a pile of what your child knows versus what your child doesn't know, and then continually practicing those that your child doesn't know. Using a timer can help to motivate your child. For instance, you could pick 10 cards, practice those 10 cards, and see how long it takes them to then complete those 10 cards. There's also some great computer games. For instance, there's a website called multiplication.com that you can use to find some very fun interactive multiplication games. If you'd like some additional tools of the non-technology variety, please attend a multiplication parent night as we have some additional games. Our last message we want you to hear about the math facts is that your child must know these multiplication math facts. Even when you think they've learned them and they know all of them, keep studying, as we find that after a summer or maybe even just after a few weeks of not studying, students actually begin to forget them or just lose their speed. So please keep studying.
We have reached the end of the presentation. There are various ways you can help your child at home with multiplication. One way is to help your child learn the multiplication facts from 0 times 0 to 12 times 12, and then continue practicing the facts after they have memorized them. You can also allow your child to use the strategies that they learned in school and encourage that your child completes all homework, providing a quiet and comfortable space to get this done. Also, resist the temptation to teach your child how you learn to do multiplication. Know that if you are going to use that to help your child complete homework, try to make connections between the way you learned multiplication and the way he or she is learning multiplication. Thank you for taking the time to watch this presentation. If you have any further questions or comments, you're welcome to call us at the Math Lab. The number at the school is 476-6541. You can ask for the Math Lab, and we'd be happy to talk to you and sit down and answer any of your questions you might have. If you have further questions, you can come to one of our parent nights and ask the questions then, when we'll be going through the same presentation